Part B, they want us to find the resistance at not S prime, but S, the resistance at 1.5. So we will plug it in. Here it is. So I have 1 over 1 divided by, you know me already, I have to have parentheses and everything, but that's me. Some calculators don't require parentheses, but others do. So I don't know what type of calculator you have. So it's 0.1975. 0.1975. Find the rate of change of resistance with respect to R when R equals 0.8. The rate of change now. It's a different story. So this is S prime of 0.8. S prime of 0.8 will be -4 divided by, again, that's me, parentheses, 0.8 and power 5. -12.21. What does that mean, and what is the measurement unit? As you notice, we do not have, they did not give us the units of resistance. So I'm just going to write units of resistance. They're not telling us what that is. So what is the measurement unit for the rate of change? And then we can talk about the product and the quotient rules. So whenever, yes, I'm sorry.
Would it be millimeters over?
So it's the rate of change of resistance. So units of resistance over per
millimeter.
Yes, per millimeter. And the fact that it's negative, what does that imply? That when the radius is 0.8 millimeters, the rate of change of resistance is decreasing with this rate. At that instant, units of resistance per millimeter, per each millimeter. Okay, moving on. Any questions? Any questions? Okay, so let's look at, we already presented the product rule, so now we are ready to use it. On page, please choose page 154. Let me start one and then you choose the next one. I'm going to start with 6. And we have g of x equals 4x squared multiplied by x cubed plus 5x. And if somebody says, why are you using the product rule? Just simply distribute. 4x squared times x cubed is 4x to the 5th. 4x squared times 5x is 20x cubed. And you're done. And just differentiate. True. But we want to practice the product rule, and you'll see why. Very soon. Very soon. So this is function 1 that is multiplied by function 2. We are not going to distribute. This is a blink, right? A g prime will be 20x to the 4th plus 60x squared. And we're done. We have the answer. But we need to practice the product rule. So then g prime, remember, when we differentiate a product, we have to have a sum of 2 terms, of 2 products. When I differentiate the first function, so let me refresh your memory, first function prime times the second plus the first times the second function prime. So when I differentiate the first one, I have 8x. This is it. Now times the second one, which is x cubed plus 5x. I can't touch that. I cannot do anything to it. Now I copy the first one and I differentiate the second one. I know how to differentiate x cubed. We just did it together an hour ago or 45 minutes ago. And then plus 5. Yes, I will have to distribute and make sure that I get the same thing. So 8x times x cubed is 8x to the 4th. 8x times 5x is 40x squared. 4x squared times 3x squared is 12x to the 4th. And 4x squared times 5 is 20x squared. This with this has to give us the 20x to the 4th. And this has to give us the 60x squared. The reason why we practice the product rule is not for this, really. I mean, it's for, we practice it for something else, which follows after this section, which is the chain rule. Any questions on this? Would you like to choose the next one?
Can we do number 9?
Number 9. Number 9 is f of x equals 2x plus 5. Everything multiplied by 3x squared minus 4x plus 1. Did I copy the correct one? So keep an eye, because sometimes I say 9 and I copy 10. Not because I don't know what 9 is, it's just that I just simply copy 10. Okay. Yes, it's very easy to distribute and we are done in a blink, but we want to practice the product rule. I don't think that this is a good color. Good. So the product rule, I differentiate the first function and I get 2. It's a linear function. It's slow. I multiply by the second one and then plus. I copy the first one and I multiply it by the derivative of the second function, 6x minus 4. Can I leave it alone? No. I have to distribute. So 2 distributed here will be 6x squared minus 8x plus 2. 2x distributed here will be plus 12. 12x squared minus 8x plus 30x and minus 20. Yes, I have to combine like terms and present it in descending order. 6x squared with the 12x squared is 18x squared. Now this is negative 16 plus 30 is positive 14. So these. And then 2 minus 20 is negative 18. Did we get the idea of the product rule? Or do we need more examples with the product rule, or can we look at the quotient? What do you think?
Number 11?
Number 11 it is. And we have f of t, the square root of t plus 2 multiplied by 3t minus 4 the square root of t and plus 7. I hope I copied the one you wanted. Good, yes, I would distribute normally and get it over with and simplify as much as possible, but now we really want to practice the product rule. Good, so then f prime of t. When I differentiate the first function, and that we have to remember, the square root of t prime is 1 over 2 the square root of t. It will save us a lot of time and aggravation if we don't do that. If we don't remember that, it's going to be more difficult. So when I differentiate the first function, I get 1 over 2 the square root of t multiplied by all this, 3t minus 4 the square root of t, and plus 7, plus, I copy the first function, and now I will differentiate the second one. When I differentiate 3t, I get 3. When I differentiate 7, I get 0, but this is negative 4, and when I differentiate the square root of t, I know is 1 over 2 the square root of t. And yes, I have to distribute and simplify it fully. Any questions so far? Okay, so I'm moving on. Good. So 1 over 2 the square root of t multiplied by 3t will be 3t over 2 the square root of t. But when I multiply here, the square root of t will go away, and I will only get negative 2. Now I have to distribute it to 7, and I get plus 7 over 2 the square root of t. Plus, here I have two terms to distribute, the square root of t to 3 and the square root of t to this term, and then 2 to 3 and 2 to this term. Messy. Whoever chose this one will not choose again. I'm kidding. I'm kidding. Sorry. It's just a joke. Okay, plus 3 the square root of t. The square root of t times, let me simplify it here. So the square root of t times 2 over the square root of t will just be negative 2. So I distribute it to 3, and I distribute it to 1 over the square root of t, so it's just negative 2. Now 2 times 3 will be positive 6, and 2 times 2 over the square root of t with minus in front will be negative 4 over the square root of t. Yes, it's not done yet. So let's see how we clean this up a little bit. And I see that any questions on the multiplication here? Any questions? I'm checking one more time because I talked too much and just making sure that I didn't miss anything. Yes, it is negative 2 and this 6, and it is yes. Good, so let's continue. These two have the same denominator, so I will write 3t plus 7 over 2 the square root of t. These are done. 6 minus 4 will be positive 2. And then plus 3 the square root of t, which is alone by itself, and minus 4 over the square root of t. Can anyone give us the least common denominator of these 4 quantities? So I can put it in. Least common denominator. Anyone? What do you think? Well, the least common denominator is 2 the square root of t. There is nothing else. This is the same. This is over 1, so it needs a 2 the square root of t. This is over 1, so it needs a 2 the square root of t. This is over the square root of t, so it only needs a 2. Copy 3t plus 7 plus this product, 4 the square root of t. This product, 2 times 3 is 6, but these two, when I multiply them, I get a t. So plus 6t. and minus 8. Okay, finally, 60 plus 3t, 9t, plus 4 the square root of t, and minus 1, and over 2 the square root of t. It was an interesting problem. I agree. Any questions? Let's look at the quotient rule now. Would you like to choose from 13 through 20 or anything that has a quotient in it?
17.
17. Where are you? 17. I see it. G of x equals 8x cubed minus 1, everything divided by 2x minus 1. So it says use the quotient rule and so on and so forth. Okay, so now the top is function 1, the denominator is function 2. The formula is different. Now the quotient rule. So g prime, the denominator just gets squared in the denominator, and we differentiate the numerator, bringing 3 down, so 24x squared, 1 prime is 0, multiplied by the denominator, now minus the numerator, multiplied by the denominator prime. And there is nothing else, but now we have to try to simplify it. I noticed that these two terms have 2 in common. I want to take it out. So 12x squared distributed to 2x. So 24x cubed. 12x squared distributed to negative 1. This is gone. Minus 8x cubed and plus 1 over 2x minus 1 squared. See if you have any questions before we continue.
Where did you get the 12x from?
I pulled out from both terms, I pulled out the 2.
Oh, okay.
So this now becomes 12. So 12x squared times 2x and 12x squared times negative 1. And this is gone. It's right here in front. Minus 8x cubed and plus 1.
Okay, got it.
Good. Always try to simplify as much as possible. So 24x cubed minus 8 is 16x cubed, and then minus 12x squared, and then plus 1, and then 2x minus 1 in the denominator. Never expand the denominator. Do not expand denominators. If they're factors, if there is a squared of 2x minus 1 or something like that, do not expand them, please. Okay, I'd like to look at a word problem and then you choose anything else you want. I would like to look at 62 and then we can go back to the previous page. Any questions? You can write it with a 2 in front, you can write a 2 in front and put parentheses at the top, it's up to you.